So in this week, on Wednesday, we will have our exam 2, and I hope you take time to prepare for the exam 2, since the exam will take up 20% of your final grade. And the exam 2 will start at 3 p.m. on Wednesday and end on Sunday 3 p.m. So the exam lasts 1 hour on Cengage now, and you can take any times. However, once you started, you must finish within 1 hour. So for this video, I will help you to prepare for the analysis question, which count for 80 points for this exam. And you will see one simple linear regression model and one multiple regression model. So in this video, I will emphasize the key concept which you may see in exam 2. So you can download this file from the D2L, this week's content as well. So I highly recommend you to download this file before you start watching this video. The second thing I want to mention is about exam 2. So for exam 2, the dataset will be attached on the Cengage Now questions. So you don't need to worry about to check the email before you start exam 2. Once you start exam 2, you will see there is a button on the simple linear regression model and the multiple regression model called web file. By clicking that icon, you can download the dataset. It will be similar like your Cengage Now homework, where you can download the dataset by clicking the web file. If you have any question, feel free to email me. So let's start to review the chapter 14 and 15 to prepare for the analysis question. So the first, I list the 9 questions, and you should see all of them in both simple linear regression model and a multiple regression model. And you will find they are similar. The only difference is in the multiple regression model where I have more than one x. And now you want to ask me why we repeat those 9 questions. So actually, those 9 questions is step by step to analyze the data. At the end of this semester, you should be able to answer all of those questions given a data set. And the next you need to do is try to combine those information into paragraphs to write down a good statistic report. So the first question, if you try to remember Excel homework 4 and 5, you should realize the first question I always ask you, what is an estimated regression equation? And at the same time ask you interpret the slope or the partial coefficient, B. So far you should be very familiar. We always find the estimated regression equation from the third part of our regression output. So if you look at the second page of this handout, you will find I put an example there. So the third table showing you intercept, age, number of the pairs, marital status, and the gender. So in this case, the B0 is 50.70885, and B1 is 0.0368. So I will write it down. So the regression equation for this question is y hat equal to 55.7885 plus 0.0368 x1 plus 3.0561 x2 plus not plus, so minus 22.0072 x3, and the last one plus 12.5359. So this is the estimated regression equation. And so how can you interpret, for instance, the last number 12.5359? So if you try to look at this example, actually it's from the Excel homework 5 about the consumers' willingness to pay for the Nike shoes. And if you check my answer key, when I interpret the 12.5359, I said compare with the female male are willing to pay $12.5359 more, given the rest of the variable as constant. So there is the two key words for this interpretation. First, the gender is a categorical variable, and as I mentioned in the previous lecture, if you do the interpretation, you need to make sure you know which is the basic level. So the basic level, based on our definition, is our female. So which means when you do the interpretation, you need to let me know which level you're compared to. So it is compared to the female. The male are willingness to pay $12.59 more. And don't forget about the last phrase. We will keep the rest of variable x1, x2, x3 as constant. So this is how you can interpret the categorical variable. And now, how can you interpret for instance, about the first 0.0368? So for this is about age. So this is a quantitative variable. When you interpret this 0.0368, this B1, it will be a little bit different compared with the B4. So the B1 is similar as you interpret the slope. It is as the consumer's age increase 1 year old, the consumer is willingness to pay $0.0368 more. And don't forget about last phrase, given x2, x3, x4 as constant. So this is how you can finish the question related to estimated regression equation. And the second question, what is the goodness of fit of your model? So as I mentioned in the lecture, the goodness fit is measured by the R square, so which is here. So we got 23.91%. So in R square, in order to interpret R square, we will say 29.91% of variation in the price is in the willingness to pay for the Nike shoes is explained by the regression model. So that is how you should interpret R square. So the next question is, where can we find R, the coefficient of correlation? So the coefficient of correlation is coming from multiple R plus the sine of the slope. So here is 0.4890, and if we're looking at the simple linear regression model, we still have a sine. It depends on the slope, sine of the slope. So if the slope is negative, the R will be negative 0.4890. If the slope is negative, so he will be negative 0.4890. So next question is, how can you interpret this slope? So you need to interpret it from the following aspect. The first is the strength of the relationship. The second is the direction. So if you have R, the absolute value of R is close to 1, we will have a strong relationship. If the R is smaller than 0.5, and we will say it has a weak relationship. And the direction is decided by the sign of your R. If the R is positive, we have the direct relationship or positive relationship. If the R is negative, and we will have a negative relationship or inverse relationship. So that is how you should answer the question related to the goodness of fit or the coefficient of correlation. Again, pay attention on the coefficient of correlation R. Especially the interpretation, you need to reflect the two information, strength and the direction. And question number 3, is your model as a whole significant? So how can you do the interpretation? How can you answer this question? Actually, if you want to test the significance of the whole model, we will use global F-test. So for this test, I will require you to write down the 4 steps. So the first step is hypothesis H0. So in this case, we have B1, B2, B3, and B4. So the H0 is B1 equal to B2 equal to B3 equal to B4 equal to 0. And the H alternative is 1 or more betas not equal to 0. So in the exam, if you have trouble to type in the beta 1, you can use capital B to substitute the beta. You just need to distinguish the smaller b and the capital B. So this is the first step, H0. And the second step is the p-value. So where can you find the p-value? So the p-value always comes from the significance f tag. So that's 0.0218. And so step 3 is reject region. We always use the same reject region if p-value smaller than alpha and reject H0. And step 4, decision and the conclusion. Given the p-value is 0.0218, if alpha we choose 0.05, so the p-value is smaller than 0.05, so the decision is reject H0. And the conclusion is the regression model is significant. So this is about the global f-tests. So the next, do any of your x variable not significant affect the y variable? So we have two approaches. The first is individual t-tests. The second, we can use the confidence interval for betas. So for instance, if we want to see the significance of h, so we can look at the confidence interval for h. So where is it? So confidence interval for beta 1, for beta 1 is, you can find it from here, is from negative 0.6890 to positive 0.7625. So in this case, 0 is included. Then the h is not significantly affected the willingness to pay for the Nike shoes. So the confidence interval for the partial coefficient is the best and most efficient way to work on when we have the Excel output. So question number 5, choose the estimated value for x and use your model to predict the y value. So in this case, after you get the value model in the question number 1, what you need to do is you plug in the value of x and get y hat. So given the answer from 5, find the 95% confidence interval for mean of y. So for this question, and you first need to know we are looking at the simple or multiple regression model. So if it is simple linear regression model, the formula we will use is y hat plus minus and t statistics and standard error and the square root 1 over n plus x minus x bar. So the x will be given from the question itself, divided by n minus 1 as sample variance of x. So in this formula, the t statistic equal to t inverse alpha, normally 0.05, common, and degree of freedom of residual. So the degree of freedom of residual you can find from Excel output here. So this is for the simple linear regression model. If we are working on the multiple regression model, the formula will be easier. Y hat equal to y hat plus minus the t statistic divided by t statistic and the standard error divided by square root of n. So the standard error and the s here, they are coming from the same place. It's the standard error in the first table. So in this case, it's 26.5470. So that is for the confidence interval. So you also can work on the prediction interval. The only thing changed is in the simple linear regression model, we will have 1 plus in the square root. And for the multiple regression model, we don't divide by square root of n. Then we got our confidence interval for the individual y. So in order to prepare chapter 14 and 15, again, I require you to watch to look at the answer key for homework 4 and homework 5 to learn first how to find the answer, second, how to do the interpretation. So the question 8 and 9 is related to the diagnostics, and outliers use different plot, and you should watch another video.